Okay, circles and parabolas, here we go. Major arc, remember, 3 letters. 3 letters. Oh my goodness, I can't write. To name. And greater than 180 degrees. Okay, so I'm going to go from B over to G all the way to C. B, G, C. You might have labeled one different, but I just picked B, G, C. Okay, minor arc. 2 letters. And less than 180. All right, so minor arc, I'm just going to go EB. From E to B. 2 letters, less than 180. Semicircle, 3 letters. Must be 180 degrees. So I'm going to go from K to E to G. I could even say KBG if I wanted. So I'm just going to do, I guess I'll do KBG. Okay, and then central angle. Vertex right on the center. All right, so let's say EDG. It's a little vertex, the pointy part is right at the center. So angle EDG. All right, inscribed angle. The vertex is going to be on the side of the circle. Okay, so I'm going to just say KGC. From K down to G, up to C. Angle KGC. Okay, so let's go ahead and let's figure some of these out. The measure of angle HMJ. So from H over to M out to J. Okay, first thing, that's an inscribed angle. And if you notice, it's crossing at the diameter, right? Right through where the circle is. That makes it a 90 degrees because all of this right here would be a semicircle. And an inscribed angle is always half of that, so it would be 90 degrees. Next up is angle from M to H to J. So this angle now, I'll use a greenish color here, right here. Okay, well we know that this is the diameter, it cuts it in half. So I want to figure out what this arc is because this inscribed angle is going to be half as much. So I'm going to do 180 minus 62, and I'm going to get 118 for this arc. To find that angle, I'm going to do 118. I'm going to divide it by 2, and I'm going to get 59. So this angle right here is 59 degrees. Right? Again, I found this piece by subtracting from 180. 62 from 180 gave me 118. Since it's an inscribed angle, it's half as much of its arc, so I divided 118 by 2 and got 59. Okay, next up is KL. KL is right here. Right here. Okay, and this would be 82 out here because central angles and their arcs are congruent, and this would be 47. So I'm going to do 180 minus 47 minus 82, and I am going to get 51. So I would know that this arc is 51 degrees, KL. Next up is HLJ, and that's an arc again, right? So I'm going to go from H all the way over to L to J. And look at that. That's a semicircle, so I know it's exactly 180 degrees. And last one is LJM. So let me find a color. I haven't used pink yet. So from L to J to M. Ooh, well that's kind of nice because I know that this bit is 82 and that this bit is 118. So when I add those together, I'm going to get 200 degrees from L to J to M. Okay, so now, given that BAC, this angle right here, is 9x plus 14, and that BDC, this angle right here, is 15x minus 22, solve for x and MBC, and arc BC, sorry. Okay, well first thing I can do is I can go ahead and set those two expressions equal to each other, oops, if you could see them, because they are intercepting the same arc BC. So I'm going to switch to a color that's a little bit more visible. I'm going to have 9x plus 14 equals 15x minus 22. Right? I'm going to move 9x over, move 9x over, and I'm going to end up with 14 equals 6x minus 22. And I'll add 22 and add 22 and get 36 equals 6x. X equals 6. Okay, so now I'm going to plug x into either of these because I want to find this arc. So I'm going to go ahead and do 9 times 6 plus 14. 9 times 6 is 54 plus 14 is going to give me 68 degrees. All right, so this angle is 68 degrees. This angle is also 68 degrees. But in order to find that arc, we're going to have to take that 68 and multiply it by 2. And that's going to give us 136 degrees. Okay, next up, it's me to find MAT. Well, right here, MHT is a central angle, so it's equal to its intercepted arc. This inscribed angle intercepts the same arc, but it's an inscribed angle, so it's half as much. So you would do 122 divided by 2, and that would give you 61. Okay, this one, remember, all radii are the same, so I would just draw a line up, and I would have this right triangle with 10 for this leg, 13 for the hypotenuse, and I'm going to use the Pythagorean theorem because there's never enough Pythagorean theorem. So 10 squared plus x squared equals 13 squared. All right, 100 plus x squared equals 169. X squared equals, well, minus 100, 69. Take the square root, x equals 8.31. Okay, keep in mind, that's only that section right there. So 8.31, which means this is also 8.31. So I need to multiply it by 2 or add them together and get 16.62. Okay, find the perimeter of this whole thing. All right, well, we know that if this is 10, then this is 10. And if this is 14, then this is 14. And if this is 9, right there, then this is 9. Oops. If this is 9, then this is 9. And if this is 8, then this is 8. So I'm going to add this whole side, which is 18, and this whole side, which is 17, and this whole side, which is 23, and this whole side, which is 24. I'm going to add them all up. 18 plus 24 plus 23 plus 17, all the sides, and get 82. Okay, write the equation of a circle in standard form, given its center and its radius. So remember, it's x plus h squared plus y plus k squared equals my radius squared. Whatever these values are right here, you've got to do the opposite. So I'm going to do x plus 8, right, because that's a negative, so I'm going to do a plus, square it, plus y minus 9, right, that's a positive 9, so negative, squared equals my radius squared, which is 144. Okay, this time my center is going to be the opposite of negative 4, so a positive 4 and a negative 7. And my radius you can either write as rad 18, or you can actually take the square root, which is 4.24. Oh, wow, you can't see any of that. I'm going to pull this camera down. Okay, so write the equation of a circle in standard form given the equation right here. Okay, so first thing I'm going to do is I'm going to group my x's. So here's an x, plus 12x plus blank. That's going to be one of them. And then my y's. So y squared minus 4y plus blank equals, and I'm going to move this 12 to the other side. Right, so minus 12. Now remember, it's all about this b term. So I'm going to take this 12, I'm going to divide it by 2, and I'm going to square it. So 6 squared, and I'm going to get 36. So now I'm going to put that 36 up here, and since I added a 36 there, I have to add a 36 here. All right, and again, it's all about this b term, so negative 4 divided by 2 and squared. It's going to be negative 2 squared, which is going to be 4. So I'm going to insert a 4 here and insert a 4 here. Okay, now it comes to factoring. So since I made a perfect square trinomial, what I have to do is look at this value. So I'm going to have x. I'm going to take the b value, divide it by 2, which is 6. And that's how I know this parenthesis. I look at this, oh, it's positive, so plus, and then I just divide it by 2. All right, so my center, I have this 6. Now y, I'm going to look here, and I see that it's negative, so I'm going to write minus, and take that 4 divided by 2, get 2 squared. Now for my radius, I just combine my like terms, and I end up with 28. This would be 40 minus 12, which would be 28. Okay, so write the equation of a parabola in standard form given this. Okay, so I'm going to go ahead, and the first thing I'm going to do is move that 28 over. So I'm going to have y minus 28 equals x plus 6x plus a blank. Right, so to get this blank, I'm going to go ahead and do 6 divided by 2 and square it, which will give me a 9. Right, that means since I added a 9 there, I need to add a 9 to this side also. So I'm going to go ahead and kind of factor a bit here. I'm going to have y plus 9 minus 28 equals x again, I look to the value of my b term here. So plus, divide that 6 by 2, 3, and square it. And I'm going to have y minus 19 equals x plus 3 squared. And then I can just move this 19 over. So plus 19 and plus 19. And that's going to be y equals x plus 3 squared plus 19. It's a positive a value, so it's going to open upward, right? And it will have a minimum, a low point. In its axis of symmetry, you look right here. You take the opposite, which is -3. And the vertex would be -3 opposite, but this one stays the same because it's not in parentheses squared, 19. Okay, so now what we're going to do is we're going to know that this opens downward. We're going to plot our vertex, which is going to be a +2 and up 5. All right, our axis of symmetry is going to be x equals -2. X equals +2, right? Because it would go down here. And it's going to approximately open downwards. Our vertex is going to be the opposite of the parenthesis here, so -2 becomes a +2, and then this outside of parentheses stays the same. Whoops, hard to see. Our last video will be factoring, and I'll see you then.